Thanks, Liz. Alrighty, so we're going to be talking today about some data modeling mistakes that people tend to make in their environments. We'll walk through a couple of those scenarios that we just saw in the poll there, and then we'll also talk real quick about some other little things there as well. So, title of this, as you see, there is Tales from the Consultant and Data Modeling Mistakes. So, these are all things that I've actually seen happen in client sites, including the little things that we're going to talk about at the very end. So it'll kind of be some of the things that we get to see as a consulting team when we go out and talk to customers. And customers come to us and say, you know, why are things not working the way that they should, or why do we have problems? That's kind of the whole premise of this Tales of the Consultant or Tales from the Consultant series that hopefully we'll be able to continue in the future here as well. So some of the things that we get to see that, you know, we get to go to a lot of different customer sites and get exposure to a lot of different scenarios out there that, you know, maybe not everybody has the advantage of being able to see before you go in to do a data modeling project in this case. So maybe you're getting ready to start a data modeling project for your warehouse, and you're just trying to figure out what the right way to do things is and what the wrong way to do things is, or you know, maybe you already have a warehouse and you're looking to improve it. So some of the things that we'll talk about today, you can kind of go back and do a little bit of a health check in your own environment to kind of see what you have that we're going to talk about and some potential areas where you can improve upon. Okay. Real quick, just before we get started here, so you guys kind of know who I am. Obviously, my name is Bradley Schacht. I'm actually a senior consultant here at Pragmatic Works. I also do some training, do some of our virtual training as well as our workshops. I do a lot of community speaking events. You'll see me at a lot of SQL Saturdays in the Southeast. If anybody's going to be at the PASS Summit this year, I'll actually be up at PASS Summit in Seattle, speaking about some using SSAS with the APS, the analytics platform that Microsoft has now. I write blogs every now and then. I've been kind of a slacker on that as of late, but I do have some blogs out there, and I try to post some of the Q&A from the webinars out there so that if you do have a question that I don't get to, you can hopefully go out there and find it later on. And then if you sit through any 5 or 10 minute period of time with me, or sit through any of my webinars, you'll probably note that I'm a big pizza fan and I really like the Atlanta Braves. So if you're a Marlins fan, we're not friends. All right, so again, these are all based on, everything that we're going to talk about today is based on something that I have seen in a customer's environment. So everything that we're going to talk about here is actually based on a true story, true things that we've actually seen. I happen to know some of when the webinar topic went out there, I actually had a couple of customers that I've worked with in the past send me emails and said, hey, are you going to talk about the following? Some of it a little bit jokingly, because we had some fun conversations about design decisions on projects and everything. But some of those you'll actually see here inside of this session today. Okay. So, you know, again, we see a lot of things. You know, customers always call us in because part of the reason why we get phone calls from customers is because we do get to see so many different things. It's not necessarily because the way that you're doing things is always the wrong approach to do them, but there's oftentimes maybe a better way to do it. So SSAS is a great example of that. You know, there's 34,000 different ways that you could probably do something in SSAS. Okay, probably not that many, but maybe 3 or 4 ways that you could do something in SSAS. But based on some things that maybe we've seen at other customer sites for similar data, that type of thing, we can kind of help you guys, you know, help you choose the most optimal way to do that. Okay. So again, today we're going to talk about data modeling. What we're going to try to do is take a couple of these, we'll talk about the scenario, and then maybe walk through some of the ETL and show you some of the downstream effects of your data warehousing and your data modeling decisions. So data modeling doesn't affect just the queries that you get to run against your data on T-SQL. It also affects everything downstream. So all your reporting services reports, it also affects your ETL that loads into that data model, and then of course all your AS cubes and anything else that you have downstream there as well. So we'll take a couple of these scenarios and look at different pieces of those as we go along here. Something to keep in mind, and this is something that always comes up, is just because it works doesn't mean it's the way that you should do it. Okay? So just because you have one successful example of the way something was done doesn't mean that it's the right way to do it. And we'll hopefully see that illustrated as we go through some of these. So just keep that in mind as we go through here. Just because it works doesn't mean that it's right. Okay, so we have three larger topics that we're going to try to go through here. We'll talk about surrogate keys. We'll talk about that second scenario that we had in that poll there, where we said that we had a bunch of extra flag fields inside of our fact table, maybe that don't need to be there. So we'll talk about junk dimensions and how to implement one of those. We'll talk about dynamic data models, some of the things that I've seen with those, and why they don't work so fantastically well for you. And then quick hits, I've got like 7 or 8 different little micro topics here that we'll kind of run through at the very end. Just some, again, some health check kind of things, some do's and don'ts for your data model, just to make sure that you're kind of doing things in the right manner there at the very end of the session here. If you guys have questions throughout, feel free to put any questions that you have in the chat box there. Again, I will try to get to some of those here at the very end. I'm going to try to leave a little bit of time at the end to hopefully answer some of your data modeling questions. And if I don't have any time there at the end, or maybe we don't get to all of them, then I'll have Liz pass those over to me and hopefully get those into a blog and get those answered on my blog there for you guys later on, which I'll put that back up on the screen a little bit later. Okay. All right, first topic here, surrogate keys. So surrogate keys inside of your data warehouse are quite vital to having a good warehouse performance, for one, but also having a flexible data model that will allow you to add new data sources and also track history and do a whole host of different things inside your warehouse. So surrogate keys, while not every customer necessarily uses them, and maybe you don't need them right now, but they're always a good idea to implement those. So make sure that you're always putting surrogate keys into your data warehouse. So this right here is what you would probably see of a data model that has no surrogate keys on it. So what you'll notice in like the very middle table there, that salesperson table, all they have is a salesperson ID. There's a territory ID that goes to foreign key relationship there, over to the sales territory table, but we only have a single ID inside of there. That provides us with a host of issues. So one, if we want to track history, which is one of the primary reasons why you build a data warehouse, if we want to be able to track history, how do we know which version of the record we're looking at? Or how do we even track history without having our surrogate key inside of there? If we need to combine data from multiple sources, how do we do that? We've only got the one key value from the original source system here. So if we acquire another company and we have to combine that data in, what does the salesperson IDs overlap? Or what if one company uses an integer field for salesperson ID and another one uses a varchar? So there's a whole host of reasons, again, why we might want to use surrogate keys. So again, one of the main reasons is history, keeping history on our data. So if this is what my data looks like, on the right-hand side, I've got my dim customer table, where I've got my customer ID, my first name, last name, and my couple of address lines there. And then over on the left-hand side, we've got some new data coming in, and you'll notice the address and the zip code are different between the two. So what we're going to end up doing, if we have the data model that you saw on the previous screen there, is we're going to go and we're going to issue an update statement against the table. So far, so good, right? Update the data. We've got the most recent version of the data inside of our table there, and we're good to go. Well, that's not going to hurt any of your reporting today. Not going to cause you any issues with your ETL or anything like that. You're not really going to see the effects until somebody comes to you and they say, well, I need to know how much this customer purchased when they lived in Florida versus how much the customer purchased when they lived in New York State, so that we can do some analysis on that and figure out whether our customers in Florida are spending more money than our customers in New York State. So we want to take a look at the customers that have moved between the two states to see if their purchase habits change, and if we can then apply that logic to other customers that already live in New York or customers that already live in Florida, and we can adjust our marketing to account for that. So the problem that we end up with here is that we don't know what this person's previous address was. All we ever have is the current version of their address. If we only have the current version of their address, we might as well be doing reporting off of our source system or off of our OLTP system. Not that I necessarily recommend doing that, but that's essentially what we get, is we get the same thing in our warehouse that we have inside of our source system. And if your warehouse tables look exactly like your source system tables, then you're probably doing your data warehouse wrong. Okay? So that's one of the big advantages of surrogate keys is we get from the situation of where did my history go to being able to track that. So surrogate keys, again, do a couple of different things here for us. One, they isolate us from source changes. So I mentioned just a minute ago that maybe we acquire another company or we bring in another source system or maybe we're switching ERPs and we have different key values and all those type of things. There are probably half a dozen to a dozen different business changes that could happen that would cause downstream effects on our data warehouse. Okay? So by adding these surrogate keys in there, we can actually isolate our data warehouse from source system changes and make it handle those source system changes a little bit better. So again, let's say that you work in the banking industry, and we all know that banks acquire each other left and right. Okay? They merge all over the place. So let's say that Bank A out there goes and acquires Bank B. Well, now you need to merge those two data sets into your data warehouse because you're now one company. You need to treat all your customers in the same manner and do the same kind of reporting across both portions of your banking industry or your bank there. Okay? So we want to be able to combine those together. So it provides us kind of a dummy key, a new key value, if you will, for your data warehouse and isolates us from the issue of, well, one of those banks uses integer, one of them uses a varchar field. Okay? The other thing that you're going to be able to get from this, and this is the big one, is you're going to be able to track historical changes. Okay? So you'll actually see, I'll show you here in just a minute how this actually works, but you're going to be able to track historical changes where you wouldn't necessarily be able to track that in your current system. That's not to say that if you don't use surrogate keys you can't track history, but it makes things very, very difficult because you end up having to add all these date fields onto the table, and then you have to join on the ID field, but you also have to look at where the fact date was between the start date and the end date on records. And it kind of makes your join logic a little bit fuzzy. Doesn't make it perform as well because there's those extra join criteria inside of there. And it's really not it's not intuitive for your users to be able to go out there and take a look at the data. They're going to get confused, I guarantee it. Okay? So the way that we track those historical changes very easily is you'll notice that we have a couple of extra fields inside of our table over here on the left-hand side that I've highlighted for you. So instead of just having a source system key, which would be that maybe that promotion ID there, we now have an alternate key and a surrogate key. So you'll see that sometimes called promotion SK, promotion AK. In this particular data model, you'll see it's just called promotion key and promotion alternate key there. The other thing that you'll notice down at the bottom is we do track the start date and the end date for the record. So anytime that there's a change, we know the time period for which that record was valid. And that's going to be useful for loading our data into the warehouse. Not necessarily for all your reporting needs, but definitely for loading data into the warehouse. That's how we're going to go look up and find the appropriate surrogate key for loading there. The other thing that I kind of briefly alluded to there was the join. So this is going to be a smaller data type potentially, just a much simpler join. So all these keys are going to be integer values. You might end up with big int depending on the size of the dimension or the size of your fact tables, those type of things. But in general, it's going to keep those join columns very small and make those joins very simple. So instead of having to join on promotion key and then doing a between start date, end date, we only have to do a join on promotion key. Okay. So there's really three main types. There's definitely more types of attribute types, if you will, inside of data warehousing, but these are the three that you're going to see most often. You're going to see a type 0, which is a fixed attribute. That means it doesn't change. So that's going to be something like your social security number. So maybe there's data issues that might cause you to need to update the social security number, but for the most part, social security number doesn't change throughout your life. Obviously, there are some circumstances where that might happen, but for the most part, that's a fixed attribute. Gender would be another one. Birth date would be another one. These are attributes that don't change throughout your life. They stay the same, okay? Or in this case, through the life of the record. All right. A type 1 is kind of the situation that we saw a couple of slides ago where I illustrated the what happens to my change. So it's a changing value, but we don't keep any history on it. So what that means to us is if I have a record for myself, and I say that my hire date at Pragmatic Works was January 1st, 2014, and I need to go in there and update my hire date, that I don't care about tracking a change on that. All I want to do is issue an update to it and keep one version of that record inside of my database. Okay, so any updates that happen with the type 1, it means that we do not have any extra records being added to the dimension. A type 2, this is where that surrogate key comes in, and this is where your history is actually kept. So a common one to do here is going to be your address or your phone number maybe. So we want to know when somebody moves addresses. Maybe we have a different manager at a retail organization. So we want to see how the stores fare under manager A versus manager B, so that we know if it was the right decision to fire manager A for poor performance. Okay. So type 2s mean we're going to, it's a changing attribute, and we want to keep history. So that means if my address changes, I'm going to have one record for the old version of my address and one record for the new version of my address. So you'll see here, kind of same situation. You'll notice the extra columns there at the top, that customer SK, and then those two fields at the bottom where we have the start date and end date for the records. And as soon as we issue the update, we're going to go and end date the current record. So that's 7/14/2015. So we're going to put today's date in there, and then we're going to start the new record. You notice all the other information is the same. That customer ID is the same. The old address and everything stays the same on the old record. We just get the new version of the record in the database with another surrogate key. So now we can do analysis on this customer. Either one, we can do analysis based on the customer as a whole, based on their customer ID, or we can do analysis based on the different versions of this customer record by using the customer SK. So I'll show you real quick what that actually looks like in action here, and we'll take a look at a quick data model. I'll show you what surrogate keys actually look like in your warehouse, and I'll show you what this looks like in your downstream systems for your analysis services layer as well. Okay. So I'm going to pop over here to a virtual machine that I've got running here in the background. And what you'll see is I actually have two different tables here. You'll notice that this one is my my dim pizza, and I've got a couple of like type 2s or something inside of here. So I've got my type 2 table here, and then my new source data coming in. So you'll notice I've got my AK over here in this field. Again, the AK could be a variety of data types in this case. So we've got some of these pizzas. We have the AK as a varchar field. So we've got A, B, C, D, E, F, and then other ones, maybe they're from another source system that we acquired later on down the road, and those are in here as integer values. Ultimately, though, everything in here is going to relate back to a fact table using this SK field. So what you'll notice in here is that we have 4 records already inside of our database for these new versions of the records that are coming in. The only thing that's changed is going to be the manager. So we're kind of going to roll through that example where I said, you know, maybe we have a manager at a store and we fire that manager and we want to make sure that it was the right decision. So maybe we got rid of Kendra and now we've got Joe in there as our manager. Okay, so this data is coming in today, and we want to say that as of July 14th, 2015, Joe is the manager for that store, and we can then go and look and see, well, how did that store fare overall versus how did the store fare with Kendra or Joe as the manager. Okay, so I'm going to walk you real quick through a couple of ETL ways to load this. So the bad way, the first one here, and we're not going to, these aren't full ETLs by any means here, and we're definitely not going to run all these and go through all these step by step, since we want to focus on the data modeling side here. But I do quickly want to show you a couple of ways to load this. So what we have here is our source data coming in. Again, that's this data down here on the bottom. And what we're going to do is use this slowly changing dimension wizard that we have inside of SSIS, and we're going to run through that dimension wizard, and we're basically going to tell it inside of here. Let me go ahead and up and just walk you through this. We're going to tell it what the business key is, so that source system key, our pizza ID or territory ID or customer ID, whatever that ID happens to be from your source system here. And then on the next page here, this is where we say whether it's just a changing attribute, remember that was the type 1, or whether it's a historical attribute, meaning that we want to include a second version of the record every time there's a change to that. Okay? So really to do that, we just go through there, we map a couple columns at the beginning, and then here at the end we tell it how to identify those new records, and we tell it that we want to do a start date and an end date. There's some other options that you could do. My personal recommendation would always be to go start date, end date, rather than just doing a current or is not current flag type field. This will give you much more flexibility down the road if you ever want to do some more detailed reporting on like timelines and those type of things. Okay, so what we're going to do here, I'm going to go ahead and actually just run this one data flow here because I believe this one is going to do everything that I need for it to do. Okay, so it's going to go through here. It's going to pull my data in. The reason why I say this is the bad way to do it is simply because the slowly changing dimension wizard, it does what it does and only what it does, meaning it's not very flexible for you. So you can't go and put a whole lot of business logic inside of there, and it also doesn't run very hastily. So it's a little bit of a slow operation. So what you'll notice now, and actually my end dates didn't update, sorry, I forgot I need to actually set those to null inside of here because it views null as the as an active record there. But what this should say, if I had had these values here as null, is you would see that 7/14 would be the end date on the old records with Kendra, and then 7/14 would be the start date on these new records here with Joe. So we actually added 4 additional records into our data warehouse here. So the disadvantage to type 2s is that they add additional records. The advantage, though, is much, much better analytic value for us. Okay. So again, if we're looking at our pizza dimension here, here's the correct version of it. So I actually went in and I set kind of the middle of the year is where I wanted to draw that line. So you'll see all those new records, all the new versions in here are records 9, 10, 11, and 12. So if I go in, I look at my fact table for all the orders that I've done on pizzas, and I look at all the SKs of greater than 8. So all of these records where Joe was the manager. What you're going to notice inside of here is that my date SK on these, all these dates are greater than 7/28. So you'll notice that all the dates where Joe was the manager on any of my orders was after the date of 7/28. So that's what we ultimately end up with inside of our warehouse here. Real quick, 2 other ways to load this data. The good way here, one of the good ways, is to use a lookup command and then do a conditional split. So inside of our conditional split, we essentially just tell it what our type 1 columns are, what our type 2 columns are, and then we do a little bit of conditional logic. We stage those updates into tables, and then afterward we go and we run an update statement. I believe we have some other webinars if you guys are interested in a little bit more of how to do this. There's also some really great blogs out there on some type 2 dimension loading methodologies out there for you. Last version that we have in here, again, real quick, we'll just look through this one here. There's actually, bring in all of our source data, bring in all of our existing data, and then we use one of the Pragmatic Works tools that Task Factory Dimension Merge Slowly Changing Dimension. We just tell it how all the columns map up there. It determines all of the new updated SCD1, SCD2s, and we just put those out to their respective destinations, and we're done with it. Okay, so three ways to be able to load our data warehouse there. Again, using that SCD wizard should be your last resort there. Okay, one last thing before we move on to the next topic, I just want to show you how this actually looks from an analytics standpoint and why you would actually want to do this. So what I've got on my screen here right now is I have my average delicious index. So basically, this field right here I basically built a database that says I ordered this pizza, and on a scale of 1 to 100, I enjoyed the pepperoni and ham pizza. I rated that overall as a 93%. 93 out of 100 is what I've made my delicious index there. Okay, the pepperoni extreme, I like that one a bit less. I rated that one 56 out of 100. Okay, so we can see here analysis based on those pizzas over all time. And once again, just to show you guys what the dimension looks like here, what I'm doing is I'm basing this off the pizza name. So this would be based off this AK field here, or just the overall just cheese record. If I want to then break this down by manager, this is the advantage of having that type 2, is I can come in here and I can drag in just the managers, and actually let's put it down here and see what that looks like for us. So we can see here by looking at this, there's my overall rating for the all-pig pizza, but we can see that once Joe took over, I had a significantly worse experience with that particular pizza. Same thing down here with the Just Cheese pizza. Looks like once Joe took over as the manager, I didn't enjoy it nearly as much. I only ordered that pepperoni and ham pizza while Kendra was the manager, so things look like they're all good there. And then same thing here with the pepperoni extreme. So it looks like as soon as Joe took over, my satisfaction with that particular pizza dropped dramatically. So one of the great things that we can do with these type 2s is even though we only have one pepperoni extreme pizza, we can track these different type 2 attributes and be able to look at this data either over time with the changes in those type 2s as we're doing here with the manager, or I don't have to, I'm not forced to look at the type 2s in there, and my users can still continue to browse the data without taking into account those type 2 attributes. So there's a lot of flexibility that we gain by using those type 2 attributes inside of our warehouse there. Okay. The next thing up, we're going to talk about junk dimensions. So these are, in my opinion, kind of an underutilized tool that you have in your tool belt. So a junk dimension is basically just a place to store additional attributes that aren't related to any particular dimension. Most commonly, again, you're going to see these inside of your fact tables, and most commonly they're going to be things like text fields or flags or indicator type fields. So maybe you've got an order table, a fact table that lists all the orders that were placed. Maybe you have a field inside of there, maybe you want to analyze your data and say, well, show me all the orders where somebody used a coupon. So maybe you decide you want to put a coupon, yes or no, kind of a field inside of your fact table. Well, over time, there might be a large number of those fields, and it might not be efficient to store those inside of your fact table. So a junk dimension is a place for us to take all those flag fields. So did they use a coupon? Did they place the order online? Did they place the order over the phone? Did they have to call customer service during the order? Did they have to use our online chat during the order? There could be a whole number of these. Then there's some text fields too. So maybe they did call customer support and you require your reps to go and type in some free text fields in there in order to, or pick from a drop-down list that says this customer was very satisfied, moderately satisfied, or they were super angry at me at the end of the phone call. So we might have all these different things that are relevant, but they don't really belong inside of our fact table for the reasons we're about to talk about, and they definitely don't tie into any particular dimension. Okay? So the problem here is they are required fields. We definitely need to analyze our data. We need to know how many of our orders are being placed with coupons. We need to know how many of our orders during the order process, something went wrong with our website and we had to have them contact our customer support department. We need to know how many of those people chose rush delivery as opposed to just standard delivery. Some of these things could, maybe that delivery one goes into a different dimension, but these are all things that we may store on our fact table. Okay? They're required fields for doing analysis inside of our business, but they don't necessarily, again, relate to a dimension. So the coupon, it doesn't really relate to anything other than the sale. It's directly related to our fact, but it doesn't really go inside of any dimension. We can't really cram that inside of another dimension there. Again, they are a business and analytical value, but they could be results of poor source system design. So maybe your source system just tosses a bunch of flags in there when they should be stored differently. There's a whole number of design options on the source system that could influence this on the back end. So maybe your source system stores all these different things transactionally, or maybe it doesn't store them transactionally rather, and you didn't think, well, I need to go in and store transactions inside of my fact tables or something along those lines. So your source system could influence the design of your warehouse in an adverse way and cause you to have all these extra fields just sitting inside of your warehouse tables. Okay, so we have a couple of solutions here. So one, we could create additional facts. So again, we can kind of pivot that data rather than having extra columns inside of our fact table. We could go and make extra rows for each one of those different items, but that's not necessarily the right decision there. We could also separate those out into separate fact tables. So maybe maybe those particular fields don't lend themselves to pivoting, but they do lend themselves to being created into separate facts. So we make a fact coupon order. We make a fact order problem table. That's not really necessarily the right design decision, though, because then we're just going to end up with a ton of fact tables that don't really mean anything to us. You're going to have to go to different fact tables to get analytic value out of something that should be right alongside of your orders in that case. Okay? So it's either not the right decision or it's not the ideal design for either one, your ETL, or for two, more importantly, your usability of the system. Because if users can't understand the data in whatever way you decide to store it, they're not going to use the data. Okay? Can't understand it, they're not going to use it. Okay? Another solution is to create a bunch of small dimensions. Okay? So we could create a coupon fact table. We could create a had problems with, or a dimension rather. We could create a had problems with order dimension. We could create a had rush delivery dimension. But that gets really confusing to users. The reason it gets confusing to users is because we end up with, instead of our fact table in 4 or 5 dimensions related to it, we now end up with our fact table in 10 or 12 or 15 dimensions related to it. And they're all really small, and they're all just little bit fields, say yes or no inside of them. So you're doing a whole lot of this extra design work, and you're, one, just causing confusion to users, and two, it's just more work to maintain that. So you're complicating your ETL really for no gain at all there. Okay. The last option there, or one other option here, before we look at the junk dimension, is going to be to leave those in the fact table. The problem that you're going to run into there is that you've got a ton of values that are just going to get duplicated inside of there. So again, you've only got a yes or a no option for whether or not they used a coupon. Why store that across a billion different records inside your fact table, or even 100 million records inside your fact table, when you can consolidate that into a much smaller integer value that you can store in there across all the different options that you have for each one of these different fields. Okay. The other issue there is poor performing queries. So yes, you've only got 2 values inside of that field, but if you ever go and you run run queries or build an analysis services cube, you have to go and scan all those hundreds of millions of records inside of your fact table just to pull back 1 or 2 different values for each one of those fields. So analysis services is going to issue a select distinct from every single column inside your dimension. And when you have to bring your fact table in as a dimension in that case, it has to go and run a select distinct across all the hundreds of millions of records just to pull back those yes and no values. So it doesn't really lend itself to a good performing query for you just running queries on your own, or for tools like analysis services even to be able to go and run queries against it to load your cubes. Okay? So this is what it would end up looking like if we were to break these all out and we made a bunch of little small dimensions here. So you'll notice in the middle, I've got my fact pizza order there. And then I have an SK for coupons, I have an SK for paid online, and an SK for delivery. Okay? All those tables only store 2 values. They store a yes and they store a no. Okay? Again, another option here is to leave those in the fact table. Again, not an ideal situation. Here we end up with either a bit field, a 1 or a 0, or maybe we end up with a varchar field that stores a Y or an N inside of the table there. And we end up with a bunch of extra columns inside of our table, again, that we have to bring in inside of analysis services. The last option, this is the one we're going to look at how to actually build here real quick, is the junk dimension. So all we do is we add 1 column into our fact table, junk SK, and then we're going to create a separate dimension. In this case, we're calling it dim junk, and we put each one of those different flags in there in a separate field. So we basically just take those 3 fields that we would have stored inside of our fact table, and we move them into their own dimension. This keeps our fact table a little bit more narrow, and it gives our users one place to go to find all these little flags that are related to our fact table, and it also makes all of our queries much more efficient because it's an inner join using an integer value, and analysis services is going to be able to process that dimension much quicker than it is going to be able to scan that entire fact table to bring this in as a dimension. Okay? There's 2 ways that we can go about actually populating this. Okay? We can either go and do a select, probably not a select star, that probably shouldn't have been what I put in there, but we're going to go and do a select from our fact table, and we're going to populate our junk dimension with only the existing combinations. So just real quick, if we have these 3 combinations here, we have a yes and a no on each one of those. We could have a yes, 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 a no, 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 a yes, no, no, a yes, no, yes, and so on until we come up with all these different combinations. So we have two ways to load this. One is we go and we only pull in the combinations that appear in our data. That's going to keep our dimension a little bit smaller, so it's going to be a more efficient dimension, but it does complicate your loading pattern a little bit because you have to look at the data coming in and make sure that you have all the combinations from the new data that's coming in, as well as all the existing data in your fact table to make sure you account for all those combinations in your dimension as well. It also means that every time you load your fact table, you have to worry about potentially reloading or loading additional data into your junk dimension. Okay? So it's good in that it keeps your dimension small, but it's a little bit more complicated in that you have to continually maintain that dimension over time. The other option, which I'll show you, is how to cross-join all the different options together. This is good in that you only have to populate it one time, and it has all the different combinations of those fields inside of the table. The downside, of course, is the complete opposite, is that it's a larger dimension, and you have a bunch of unused entries inside that table potentially. The good news is, though, it's a little bit easier ETL pattern because that table is preloaded for you. Okay, so let's look here real quick at how to build a junk dimension and then analyze our data using that junk dimension inside of analysis services. Okay, so we're going to hop back over here one more time, and I'm going to hop over here to my last, into this last tab that I've got open. And this is essentially all we have here, is each one of these different flags. We have a delivery flag, we have a coupon flag, and we have a paid online flag. Okay, all we need to do is we need to create one dimension that has all the combinations of all those values together. There's two ways that we said we could do that. We're going to go with the easy way first, and that's going to be to cross-join these different data sets together. So all I've done here is basically made just a CTE that lists all of my delivery flag options. I have a CTE that lists all my coupon flag options, and I have a CTE that lists all my paid online flag options. Super simple. All we have to do is take those three CTEs or those three data sets, and we just cross-join them together. And when I run that, you'll see that for those three different options, I actually end up with 8 different combinations of values there. Again, so I can have all no's, I can have all yes, and then I can have any combination in between of yes and no between all those different values. So in this case, my dimension is a little bit bigger than it needs to be, and then I have 8 values in here instead of what you'll see in just a minute is a much smaller number of values, but it's pre-populated. It means I only have to do this once. I don't have to worry about it during my ETL. Okay. The other option here is we go over into our fact table, or in this case in my stage data, and I only pull back the records or the combinations that exist. So here you'll see I've got every single combination inside my table, and I have 38 records inside the table. What I actually want to do, though, is I want to take a distinct list of those because those are really the only entries I need. So in that case, I'm down to only 2 entries. So what we've done is we've basically taken and we said, I don't need to store all 8 of these versions of that record. I only need to be a little bit more efficient, and I only need to store 2 of those records. Now, I've only got 38 records in my fact table. I've only got 3 different fields here inside my junk dimension. I can tell you from experience, I've seen junk dimensions that if you were to blow them out into all the different combinations, it would be tens of thousands or hundreds of thousands of different combinations. Because I've had customers where we go and we create the junk dimension, and it's got 15 or 20 different fields inside of there that all relate to their fact table, but it's much more efficient. Rather than having tens of thousands of records, we go and we look at the actual data, we see what's actually there by using a query like this and selecting only the distinct values that exist, and we take those tens of thousands of records down to hundreds or even a small number of small thousands of records inside, inside the data set there. So it's much more efficient, if you can, to go this route here and only pull in the combinations that you actually need. Okay? What that looks like here, this is the 2 differences between your set of ETL here, is we either populate the junk dimension with all the different combinations that exist inside of our data set. So we do that piece first, and then we come over here and we load our data. So we have our fact table, we look up all the junk values, we look up any of the other SKs that we need, and then we load them into the destination. The other option, again, of course, is we pre-populate that table. Here, all we have to do is basically just go through the ETL to do the lookups there. Without the junk dimension, sorry, this is what it would look like if we had a bunch of dimensions inside of there, was we have to do a lookup for each one of those different dimension values there. again, if we had pre-populated the junk dimension, all we would need to run is just this one step here. So you can see the ETL is drastically, the size of your ETL is drastically reduced over here, and that we only have to do one lookup inside of this fact table, whereas if we had separate dimensions for everything, we would have to do a different lookup for each one of those. Okay? So let's take a look quickly here at the analytic value of this. So if we have, here's our without our junk dimension. So if we were to implement this with a bunch of different dimensions, we would basically have to build our cube. Sorry for jumping around here, but let me show you what this would look like over here. If we had a different dimension for each one of these, you would see that we have to bring into our analysis services solution here, we have to bring in a coupon dimension, we have to bring in the delivery dimension, we have to bring in a paid online dimension, and then we have to associate each one of those into our fact table. So what that looks like to users is a bunch of clutter, because as you notice here, inside of each one of these dimensions, all I have is one value. So all I'm showing here, or one field rather. So all I'm showing is my pizzas and whether they were delivered, yes or no. In this one here, all I'm showing is my coupons, whether I used a coupon, yes or no. Looks like I didn't use very many coupons. Okay. Over here, whether I paid online, yes or no. Okay. So there's not a whole lot of value add here. We end up with a lot of clutter inside of our user interface here, but no real gain by making those all separate dimensions. Our cube, on the other hand, gets greatly simplified when we switch over to a junk dimension, because again, we would only have to create this one junk dimension here, and inside that junk dimension, we just have a different column for each one of the different flags that we want to choose. So the way that looks to the user is a greatly simplified user interface here. So we have one fact table, one junk dimension with all my options in it, and then one pizza dimension. Whereas before, we would have ended up with 2 extra dimensions in here, again, each with only one value in them, and that doesn't really get us anything in the long run. So it's much, much easier for users to be able to come in here and just look at one junk dimension and be able to choose the different flags rather than have those in here as separate dimensions, again, or take the performance hit and build this dimension based only off the data inside your fact table. Okay. One last big hit topic here before we go and talk just through a couple of little things to wrap up here. So dynamic data models. This is one that comes up much less frequently. It's much more rare than the other two situations, but it still appears more often than I would like to see it when I go and talk with customers. Okay? So what we mean by this are one of a couple of things. Either the first is that the context changes for each record inside of a table. You'll see this very common inside of a fact table. Maybe you only see in your fact table, it's called date. Okay? So there's a date field in there. Well, that field means something different whenever it's the first record inside of an order compared to what it means when there's a second record inside of an order compared to what it means when there's a third record inside of the order. So sometimes that's the right way to do things, but sometimes it's not clear to the users what those different date fields mean in the context of each one of those records. So if it's not in a usable fashion for the users to be able to determine the difference or slice the data differently inside of analysis services, then it's definitely not the right way to store the data. Okay? A field inside of a fact table should not be changing context based on the record inside of your fact table. Okay? A field should mean what the title of the field or what the name of the column is. Okay? It should not change based on which record inside of that fact table we are looking at. Dates maybe not the best example there. I've seen customers that calculate values differently. That's probably a better example for me to put inside of here, where we have a quantity field, but it's an order quantity versus an adjusted order quantity based on the type of order that the user placed. So it's not intuitive at all for our end users to be able to go in there and query this data and figure out exactly what's going on inside of the data. Okay? So changing context of a field with each individual record inside your table is a bad idea. Okay? Field has no set meaning to it. Okay? And this is the one that really bugs me the most is I'll go to customers and we'll see custom 1, custom 2, custom 3, custom 4, custom 5, all just thrown onto the end of a fact table or all just thrown onto the end of a dimension. And what they say is, well, we weren't sure what other data points we were going to need, so we just put a custom field on there that we can use for whatever we want. Well, that becomes super confusing for users, and it becomes very confusing to query off of it, and it becomes darn near impossible to do anything with inside of a tool like analysis services or any other drag and drop tool. So custom columns, they really don't have any set meaning. The data types are just out there as like a varchar 8000 or a varchar 500, just so they can put whatever they want in there. The data type may actually be an integer value that's stored inside of there, or it may be an actual varchar value that's stored inside of there. You just don't really know until you go and look at the data, and you definitely have no idea what those columns mean without having to go someplace else. Okay. And then another one, this is actually one that came up recently with a customer at one of our other consultant sites, is that the records actually change with each load. So they actually drop the data model and they rebuild the data model based on the data they're getting in. So they may have 4 or 5 different columns inside of a customer dimension table today, but when they go and reload the data tomorrow, they end up with 7 or 8 of them. Reload it 2 days from now, you're down to 6 columns. So having a data model that actually changes is probably one of the most confusing things, and it's darn near impossible to do any type of reporting on, and it's definitely going to confuse your users. It also eliminates the ability to do any type of change tracking, so we can't do any of those type 2 type of updates or changes that we wanted to take a look at that we talked about in the surrogate key section. We lose all that ability by having a data model that changes. We really lose most of that ability when we have those fields that don't have any set meaning with those custom 1, 2s, and 3s in there as well. Because how do you know, what are we actually detecting changes on? Maybe, we have to ensure that every time we load the data that we're loading the right custom value into the right custom field for that particular record. It just makes things very, very confusing, definitely not user-friendly. Okay? So ultimately, it leads to bad business decisions because it's hard to maintain, and if it's difficult for you to maintain, if it's too difficult for you to maintain to be able to just talk in plain English to somebody and quickly tell somebody how it works, then it's probably not going to be easy for users to do any reporting off of. It's probably also not going to be easy for you to do reporting off of. Those type of reports, trust me, I've been in environments where they do the custom column thing, and they're very difficult to build reports off of, whether that's reporting services or analysis services or any other tool. The queries for them become ridiculous, which I'll show you one here in a minute, and they're just not easy to look at. Okay? And if it confuses you and it's hard to report on it, it's definitely going to give the users confusing results at the end of the day. Okay? So if we did have a custom 1, custom 2 type situation, this is sort of what your data model would end up looking like. So we have our pizza table on the left with the custom columns in it, and then over on the right-hand side, we have the column name and whether that and what that custom column actually means based on the pizza location. So for Domino's, it might be one thing. For Papa John's, it might be another. Okay. What that ends up looking like inside of our actual data, you'll see here, is that I have custom 1 for Domino's is actually a comment field that I'm able to fill in. Custom 2 for Domino's are the days that I actually am allowed to order that particular pizza. For 5-star, however, custom 1 is an overall rating that I have given each of the pizzas, and custom 2 looks like it's probably the address for the location where I ordered that particular pizza from. So these columns don't really mean anything. They only have meaning in the context of an individual record. So doing reporting on this is super confusing. You can't just look at the data model and tell me what's in custom 1 and what's in custom 2, because it all depends on the context of that pizza location field. And that's not a good way to build a data model, by making your values in your table vary based on the context of another field inside the table. Okay? Ultimately, this gets very, very ugly. It's not a fun query to write. Again, I've written some queries like this, and I'll show you just a very simple version of what that looks like. So the data model gets very confusing. Your queries are even more confusing. Okay? So if we hop over here, and you see here. So what we've got, I'll actually show you the tables here real quick. I think these are in the pizza dimension. Pizza dynamic. And so here we go. So here's all my pizza dynamic table here. I've got all my pretty goods, my I like this one, so all those different comments that I put in for this particular pizza. And what I have to do is I have to join that over to another table just to figure out what this field even means. So what that ends up looking like is that I have to declare a couple of variables here. I have to go out and I have to find what custom column 1 actually means for the pizza location of Domino's. I then have to go and find what the custom column 2 means for the pizza location of Domino's. And then in order to alias my field, because keep in mind the name of this field is custom 1, in order to get a query result that has a meaningful column name in there, I then have to build a dynamic SQL statement in order to just get any data out of this table. And even at that point, this data is only good for the location of Domino's. This query becomes greatly complicated if you try to start making this more dynamic than just for one location at a time. Okay, so I have to go through all this mess here just to execute a query to get back the data for Domino's, where I can have a comments field and a days that I'm allowed to order this particular pizza on. So it's a lot of work. It's a very messy query. You'll see this is probably not even a fun query to look at, even just with these 2 fields inside of it in a very simple data model. No less when you actually put this into a real data model inside of an enterprise and try to do this over multiple custom columns, maybe 5 or 6 of them inside of a table, and then try to build any type of reporting services report on top of this, just becomes a huge nightmare. And trying to, if you've ever done anything with dynamic SQL here, you'll know that troubleshooting dynamic SQL is not a fun task. So just writing a simple query like this is one thing, but when you have to start joining tables together and then adding these custom fields in here, it just becomes a huge, huge nightmare for you at the end of the day. Okay, a couple of little quick hit things that I want to talk about here at the end, and then we'll wrap this thing up. So I've only got a couple of little things. Starting the identity value at the smallest negative number. I'm not sure if actually this was one of the folks that whenever I put this topic out there actually sent me an email and said, hey, I hope you don't talk about this one here, because we had a whole discussion about why you should or shouldn't do the smallest negative number on a dimension just to be able to fit as many values as you need into it. I don't necessarily have an issue with this outside the fact that it's a little bit confusing for users to be able to go in there, or confusing for you as the developer to be able to go in there and find your unknown values, or to be able to just go in and quickly write queries and manually type in some integer values to be able to go look for some data there. So not necessarily something that's going to kill you, but it is going to be a little bit of an annoyance to you if you always start at the smallest negative number. Hey, identity columns on date dimensions. This one it just bugs me because it's unnecessary. So we always have customers every now and then that will go and they'll just put an identity value on there instead of using like a smart key on there. So instead of, let's say your date dimension starts at 2005. So January 1st of 2005 would be record number 1, SK of 1. Well, instead of doing an SK of 1, put the integer representation of the date in there. So put 2005-0101. That way when you're doing any queries against your fact tables, you don't have to go and do a join over your dimension every time just to look up some data. You can easily type in some numbers and get your data back. It's more difficult to read whenever you use an identity column on a date dimension. It forces you to have to do a data flow lookup inside of your fact table loads, which you probably should be doing anyway, but forces you to do that there. And it's also harder to reference dates inside of MDX queries whenever you have identity values in there. So make sure MDX is a little bit easier by using those smart keys there as well. Okay, short-sighted granularity decisions. This is probably one of the biggest things that we see at customer sites. So I've had many situations where we'll be building the data model at the month level because customer says, well, that's all we needed right now. So, well, my follow-up question for you is, well, what about when you need to join that data to a daily granularity? Well, then you have to go back and you have to change all your ETL. Everything's kind of ruined at that point, and it causes you a whole bunch of rework. So I had a customer where we did shipments for their manufactured goods at the month level because that's all they wanted to track it at, was they needed to track it at the month level. Well, a couple of sprints down the road, they got this new requirement that said, well, we need to bring in the supply chain data, or we need to bring in the manufacturing data to tie it in. Well, all of our shipments are at the month level, but all of our manufacturing data needs to be at the daily level so we can track daily output and where it was shipped to. That caused a huge problem because we then had to go back and rewrite all the ETL for all the shipment data there. So it may end up being a larger data model for you to store everything at the lowest granularity, but it's definitely going to be helpful for you in the end to store everything at the lowest granularity possible in order to provide you the greatest flexibility possible, because you never know what those requirements are going to be in the future. So always go with the lowest granularity possible. Okay, my data warehouse is just a copy of the source tables. Well, that's basically that situation we talked about first off. That's really just an operational data store. If your warehouse is just a copy of all your source system tables, then I would honestly question the need for your actual data warehouse there. The data warehouse serves a lot of different purposes. The only purpose for it, it's not the only purpose for your data warehouse just to take load off of your source systems. So if your warehouse is just a copy of all your source system tables, we need to rethink that data model and provide you some better flexibility for how to track changes and do some better analytics on that data in the future there. Okay, last couple here. So we're having ETL failures on data types. We just expanded a bunch of them to a varchar 8000 or a varchar max. This caused us a massive amount of problems when we started doing our ETL for our parallel data warehouse. So this particular customer that I heard this at moved from an SMP SQL server over to a PDW, and we just had to basically redo everything. So it's not a good idea for a couple of reasons, even if you're not looking to move to a PDW. One, it takes up a bunch of stores that you don't necessarily need to take up. Two, it's kind of a lazy way to do your design there. And three, it could impact performance on things loading in. So your ETL is going to take a performance hit because SSAS uses a fixed buffer size there, and your cubes are probably also going to take a performance hit because it's trying to store all this extra data in there. Okay, so don't just go out there and put varchar max on all your fields, and don't just go out there and expand the data types on all the fields to something huge just because you have some ETL failures on the data types. Go out there, actually spend some time, do the research on it, figure out how big those fields actually need to be, and make that the size of your field, and adjust that downstream as necessary. Okay. I have an index, so I thought I didn't need statistics. Well, if you want good execution plans, then you're going to need to put statistics on your database. Stats are used to estimate the distribution of values inside your tables, the number of rows, those type of things, and all of those stats go into building good execution plans. So indexes are not, I repeat, are not a replacement for statistics. Statistics are not a replacement for indexes. So you need to have a good indexing and a good statistic strategy, because it's also not a good idea to come to me and say, well, I just put an index on all the columns because I didn't know which columns we needed to index. Okay? Over-indexing a table is just as bad as under-indexing a table. It increases storage, it increases overhead. It's just not a good way to design your system. Every single column in your warehouse should not have an index on it. There's a bunch of blogs, a bunch of white papers out there that'll give you some really good data warehouse indexing and statistics strategies if you're curious about those there. Okay, and then the last one here, we hear this almost every single project with companies that haven't done a data warehouse before, or haven't done one in a really long time, or going with this particular, the star schema methodology here for the first time, is the business said they needed every column to be a type 2. Well, no, they don't. I guarantee you the business does not need every single column in there to be type 2. You need to go to the business and say, here's the use case for your type 2s, and give me a list of things that you feel might have an analytic value to look at over time. And you need to give a little bit of pushback on that. If they come back and say, well, we want to be able to analyze everything over time, then there kind of needs to be a conversation with them that says, well, I need a little bit of proof that says, or some use cases maybe that say, here's how I'm going to use the following column to look at this particular value over time, or here's the business requirement that I haven't been able to satisfy for the last 6 months because I can't look at this particular field over time. Not every field needs to be type 2. If you go to the business and ask them about that, I guarantee you they're going to tell you that every column needs to be a type 2 when it really doesn't. Okay? So we're right at the top of the hour here, Liz, so I'm not sure that we have time for questions. If you do want to give me a couple, feel free to, but I'll go ahead and put this up on the screen here for you. So if you guys do have any questions, any follow-ups or anything like that for the webinar today, feel free to shoot me an email there at bshack@pragmaticworks.com or hit me up on Twitter or on my blog there. I'd be more than happy to answer any questions that you guys have as a follow-up to this. And hopefully you saw a couple of things in there maybe that you're doing today that you can go back and make some adjustments on, or potentially getting ready to start a new project, so you know some of the pitfalls not to fall into on your data modeling there. So Liz, I'll hand it back over to you.
Yeah, unfortunately, guys, we are out of time. So what I'll do is I know we have a lot of questions, so I'll get these over to Brad, and we will get those posted in a blog post on our site. So if you're not following us on Twitter, please do. That is the best way to keep up to date on anything, any follow-up we do in regards to webinars and whatnot. If you guys have any additional questions, please feel free to email Brad there on the screen, or you can email me directly.